So today we're going to be talking about modular, monolithic versus microservice architecture. So when and which to choose whenever you're designing your system. And this is very important due to the fact that we see system being developed each day, and without the right architecture, there might be a cost implications to the team, to the actual startup itself, and in general. So it's important to actually have a deep dive into how and when to actually choose this particular architecture whenever you're designing your system, or whenever you're making a trade-off or design patterns or system designed trade-offs whenever you're doing so for your system. So first, the reason why we do this is to uh, think about the architectural impact, and the architectural impact consists of like development speed, the release cycle. So how would you actually have this development speed whenever you're designing your architecture? So these play a very crucial role. So if you're designing a very scalable system, you would want to like think about the speed to the market, because all our goals for actually designing system is to actually like be able to go to market early enough, more than our competitors and all that. So these architectural patterns actually affects how the development speed actually takes place, and also the release cycle. So if you're designing a new feature, how long would it take for the feature to get to the market or to get to your users? So it's important for us to actually look into these impacts that these architectures actually make, then make an informed decision regarding them. So it actually affects the system scalability and the reliability. So depending on the pattern of the architecture you choose, either monolithic, which is modular, or a microservice, it actually affects the scalability, how you scale the system and how reliable those systems are. So you're thinking about downtime, you're thinking about the trade-off regarding reliability of your platform, and you're thinking about fault tolerance of your actual platform. So, and also in-depthly, we think about the team structure itself and collaboration. So the number of people in the team actually take precedence whenever you're thinking about these architectural patterns or selecting the ones you want. So if the team structure is large, if it's a medium team structure, and how collaborative they are they together? Are they in different regions? Are they in different locations and all that? So all these actually impact the architectural design you're thinking of. So then what would actually cost for, what are the poor choices? Whenever you make poor choices regarding this architectural preference, then you have high maintenance costs, which is due to the fact that you have to like maintain this architecture, and depending on the architectural pattern you choose will determine the cost of that particular system itself. So this affects the cost of maintenance itself, and also slower delivery. Previously we talked about fast development and release cycle. So if you choose an architecture that's actually not well suited for your team, then you have like slow feature delivery and operational complexities from like DevOps and all that. So would actually go more in depth into these architectural choices. So when you talk about monolithic, so you're thinking about a single application that's deployed in one unit, that is like it's deployed together, like everything from the startup. So here you would have like modules well defined, and also you have clear ownership responsibilities. So you could have a situation whereby you have like the service, the controller, and the handler, or the validation. So these are like different modules in this architecture, and they help you to have like separation of concerns. So when you do this, you actually are like having a complete application that's intertwined together, that is the actually like connected together as one, compared to when you having another kind of architecture whereby they are distributed. But the communication here is actually using interface, like you calling another function from another program. So like the controller could be calling a function from the service layer, or you could have like a namespace whereby you actually calling a module from a service layer, or you could use more like function calls itself. So in general, these are well structured, well defined modules, but they are inside the same singular unit of an application. So the application actually talks within itself. So they are more like function called namespaces, classes, and all that. You define them, you define interface inside the same application itself. So the communication is limited into that singular unit. And mostly they are using the same database. So it could be just a singular database with different tables, and those information are actually seated there. So this kind of pattern is well-defined monolithic. It's modular because those services are of different either folder structure, or you're using more like different interface implementation for this kind of service. So it's regarded as monolithic. So then what are the key strengths of it? So it's a very simple architecture, like I said. So it's just one single application unit that you can actually deploy just in a singular way. So you don't even need to have like all those overhead of like DevOps and all the likes. It's easier for you to debug because it's just a singular unit, and you have like your logs, and you can actually read through your logs to actually see where the issues are coming from. It's way easier for you to actually like navigate through the functions since they are in a singular unit. You can navigate through the functions, through the namespace, through the classes to actually see where the fault is actually coming from. And it's also important for you to have your logs whereby you are able to actually see this, and easier for you to actually test too. So you can have like your unit tests on each of those functions in the controller or the service layer or the repository itself. So these singular functions can actually be like a test suite or a test unit whereby you can actually test each functions of your application. The general controller itself, you can test that class, and it's easier for you to manage just testing just a few files compared to other service pattern. And you have faster development feedback. So when you send out a feature in this architectural pattern, which like a monolithic application, when you send out a feature, it's easier for you to like get feedback because you can actually quickly develop this feature in that particular application and ship to your users. You could add feature flags just to make sure that there are certain number of users that are actually seeing these features. But in general sense, it enables you to actually like get fast feedback from the users when they use the application or whenever they use those functions or the new features you've added. So it's easier for you to get fast feedback in this kind of architectural pattern compared to the other. And also strong transactional consistency. This is very, very important, especially in like fintech or finances, whereby it's very important for you to have consistency in data across your database. So you can have some certain number here and you're having some certain number in another database, which might be, we will still look at the mitigation in the other architecture, but monolithic, it's actually easier for you to have like consistent record across the database, since this is a singular application whereby you can actually think about how you would manage, even if you're running concurrency on the actual application, or even if you're thinking about race conditions and all that. So you can easily manage them in this monolithic architectural pattern, because this consistency can be mitigated from a way of you handling them in those particular singular units compared to when there are multiples, whereby these different transaction and different seeding is coming from various requests. So then it's more complex or more complicated in actually handling this consistency, but monolithic does a very good work with them. Then you think about the operational costs and hosting costs. So it's easier for you to actually like host a singular unit of an application compared to having multiple application hosted. So you could actually like scale it vertically because you have to like keep increasing like the computing depending on the number of users and usage. So, but then you think about the operational cost, which even the developers could like be a team of few developers. And also you think about the server itself, and the costs are actually very, very low compared to wherever you start thinking of like a higher level of integration or CID pipelines whereby you have multiple instances of the same application. So it's easier in a monolithic pattern to actually reduce this cost, and it's a very good way to start a business with. So you can actually kickstart with a monolithic, thinking about the future and managing this common test pattern. So yeah, let's move further to its limitation. So yeah, so like I said, the entire system would be developed as a singular unit. So if there is a feature change, like probably you're adding a new feature, or you're removing a feature, or you're trying to do something regarding a entire application, that means it has to be redeployed again. So you don't have this essence of you actually like deploying an application while you can guarantee an uptime of 24/7, because whenever you want to like do changes to this application, you have to redeploy the entire unit. So it's not a bit scalable if you're thinking about you having an uptime of about 99.9. So you'll be thinking about the fact that you have to still redeploy this application. And sometimes deployment times actually takes a while. So you can give an SLA agreement of about 99.9% uptime for a monolithic application. And that's like a limitation. Then you think about scaling. I think I mentioned about vertical scaling. So when you have a single application as a whole, then it's hard for you to actually scale singular components. So for this particular monolithic application, then you have to like scale as a whole instead of you having like horizontal scaling whereby you scale each component. But in monolithic, you have to like scale the entire service as a whole. So that means you have to like keep increasing the RAM, or you keep increasing the memory size, or you keep increasing the database, probably you're shredding it, or whatever it is, you just have to do it as a singular unit, which makes it a bit not scalable. Because when you talk about scalability, you might want to think about, for example, like Twitter as a whole now, then you think about more people like read tweets than actually like posting tweets. So you might want to like scale the reading, that's like the reading of record, and you might want to not to scale the writing because people don't tweet as much as people view tweets. So if you're thinking about it in a monolithic pattern, you have to scale both the tweet, both the write and the read at the same time, because these applications are not in different units. So if you're scaling everything at the same time, then you're adding more operational cost, because the cost of actually scaling itself, and those particular scale might not actually require those new machines you're adding to it. So it might just be the write that needs to be the reads that need to be scaled, not the write. So this differential way of looking at the scalability of monolithic, it's quite it's a very high limitation for scaling. So, but when you think about the other aspect of it, which is to be able to actually go to market very fast, then yeah, it could be something you want to pick on for a start. So what are the risks of it? So it could actually become tightly coupled as you go along. As you're adding more features, it becomes more tightly coupled due to the fact that each services or new features you are adding are actually interacting with various components or existing components of the actual application. Then it becomes things like legacy, big ball of mud, or whereby the boundaries are weak because these applications are not in different components. So when you're adding new features, so those features are actually talking to various functions or classes within the same application, then you can actually see that this risks of boundary become very prominent in it due to the fact that you keep adding new features, which is expected in a business. So it requires discipline to maintain modularity. So yeah, like I said before, it's you need to actually have a very, very good structure for you to maintain those boundaries between the services, because obviously you'll be adding new features, and those new features would communicate with different functions or different classes in that same application. So if you don't maintain good modularity, then you're having a situation whereby you're having like a spaghetti code, or you're having like multiple functions doing the same thing. So yeah, and it's hard for you not to scale this kind of application in the long run, especially when there are more developers involved and more users requirements coming up. So in general, this limitation are actually uh, in a way whereby you can still try to use this monolithic application for more of tests, more of user prone, whereby you don't have extended number of users or very, very large user base, but you can use it for more like test features, like going to live. And if you have a very skillful team that could actually maintain the modularity in this application, it's actually a very good fit, even though it's a limitation itself. So yeah, let's dive in further. So let's talk about what are microservices. So microservices are systems composed of multiple small services, and each of these services run independently on its own data, and it's deployed separately. So compared to monolithic, microservices are like chunks of services that are deployed independently. They have their own data. They are more like domain oriented. So in the sense that if you have a service, the service could be domain oriented in towards a particular process, not working on the entire process. So it's easier for you to have like a service that like, okay, like a banking app now, you could have a service that does transfer, a service that does bill payment, a service that does probably dispute. So all these services in general, they are isolated towards each other, though they still communicate with each other, but they are isolated from each other. So whenever a particular service is being scaled, like we talked about scaling, it's easier for you to scale the services that are well used. Like for instance, we're having a spike in uses of transfer probably during December period yeah. So you're having a spike in transfer, then you can actually like scale that transfer services instead of scaling the entire application itself. So these are like more like the advantage of this architectural pattern. We still talk more about them. So what are the communication patterns in microservices? We have the RESTful, yeah, that's like using either JSON, XML, RESTful states in general. Then we have the gRPC, that's like binary protocol, whereby you actually using binary protocol to actually send this message within the services. And we have like messaging. Messaging could be like event driven, whereby you're sending a schema type with various data information about what is going on. So the design is independent, and you can actually evolve it as time. So you can actually have more services. You can take out services you're not using. So in general, they are independent of each other, and you can actually evolve each of the services with time and what with futures and thereabout. So what are the key strengths of microservices? So first is that you can actually independently deploy these services. So you can deploy the services on its own. So you don't have to like wait for probably bills payment to actually deploy transfer. So these services are decoupled. They have like isolated and boundaries. So they don't like, they do communicate with each other, but they don't require each other to actually perform various processes. So you can easily scale the hotspots. That was the example I was giving about a scenario whereby transfer is having a high spike. Then you can actually scale it up, either adding more resources to that or creating more instant. So there you can actually do more of that horizontal scaling, whereby instead of you having more compute to the actual application itself, you can create more nodes, yeah, to the service itself, or just spin up more virtual services to actually house this and have a load balancer that would actually balance the load across. So it's easier for you to actually scale microservices compared to a monolithic. Then fault isolation. So like I said, so whenever a system is down, it doesn't affect the rest. So just one particular service is down. For instance, if the bill payment service is down, you can still make transfer. You can still create disputes. You can do wherever the other features that are services that are not down can do. Yeah, so there's no isolation of actual particular service to there's an isolation of this fault. So with the service that's down, which is the bill payment, yeah, it's down, but other services can still work. So yeah, you can still have a nice level of uptimes about 99.9 because obviously the entire service is not down. It's just some particular aspect of the service that is actually down. So it's very, very good, especially when you're thinking about uptime of about 99.9. So you can actually enable autonomous team. So yeah, this it gives rooms for diversity in teams whereby you can have different teams, like a team handling bill payment. They understand the domain of bill payment. They write the code on bill payment. They do everything in general on that bill payment. They become more of a domain expert in this, and they could actually handle that particular microservices on their own. Then another set of team could actually be a squad that actually understand transfer domain and they work majorly on transfer. So in essence, is that it actually enables teams to be able to work on their own various services and also contribute to the organizational goal. So it enables teams to be diverse and also be able to actually contribute to the organization goal. So it supports large and complex organizations. So majorly, most of the organization, Fortune companies are actually using microservices, and this is due to the fact that they have distributed teams around the world, different regions, mostly people working remotely, yeah, collaborative way. And when you're using microservices different services, you can actually actively contribute to this system without having a scenario whereby you're waiting on a particular team or a particular team member. So it's easy for you to actually collaborate and develop a feature and ship it out since the particular team owner owns a particular microservice or a service on its own. So you're able to like develop, scale this service on your own in all your teams various. So majorly, if you even look at major industries and key players like organizations that are actually doing very well, they have different squads. So they usually call them squad and they have different key goals because it's based on the domain expert of the actual product itself. So these various products that they do, they actually have domain expert in them and it's isolated towards a particular service. So it's not like you having a service that actually does different things at the same time. And when it's down, the entire organization is down. So yeah, it's something to look at when you're scaling up your organization in general. So then we talk about the challenges of microservices. So it's a complex architecture and infrastructure and tooling. So it's quite complex compared to monolithic. So then you think about platform engineering, you think about reliability, you think about the deployment, you think about the pipeline, you think about the messaging queue. So these are a lot of complexity that are involved when you're thinking about going into microservices. So then you have things like distributed system problems. So you have like network latency, partial failures, you have data consistency. Like so the latency, network latency can actually happen. Like for instance, you're communicating with another service, probably bill payment needs to communicate with accounting service to actually get the customer account balance. Then there will be an issue whereby there's latency or there's disruption in account service. So it will actually cause a network failure whereby they can actually like do like B payment. Though the B payment service is up, but you checking for account might be down. So this latency might be an issue, but it's still when it's well managed, then you can actually have a very good system itself. Then partial failures involving failures of one particular system and it's affecting the other. So then, but then if you look at this scenario, though it occur more often, but then you have this ability of retry in this distributed system. So you can actually retry based on the pattern or the event or the pattern whereby the microservices actually communicate. So you can do more of retry and you can actually mitigate this failure probably by sending in alarms to actually understand that, okay, there's a failure in this particular service and it needs to be up. Then you have the issue of data consistency. Like in monolithic, it's actually very easy since it's a singular database that actually have this information. But in microservices, it's quite a bit more different because each service has its own database. And for you to guarantee this consistency across the database, then you have to start thinking about what are the various ways to actually get this consistency. And a number of ways are actually being developed to actually resolve these. We have things like using idempotency keys to actually make sure that a request is actually the very first time that you're getting that request. So if you have an idempotency key on your request payload, then you can use that to validate the uniqueness of that particular data. So, and if you look at some services like Kafka as a broker, then you can think of how you can actually make your message idempotent. So if you're sending a message to another service, you make sure it's idempotent so you don't have multiple messages being sent. Probably when the service is down and it's back up, then you're having multiple services being multiple messages or requests being sent that has already been resolved. So it's important for you to think about how you would make sure the data consistency, though it's a limitation on microservices, but there are mitigations that you can actually take to resolve this data consistency across your services, which a number of them are actually like idempotency, context relations, and stuff that you can actually ensure that your data is consistent across all your platform. So high DevOps and monitoring efforts. So yeah, it's quite hard for you to think about microservices without you thinking of platform engineering, whereby you need DevOps engineers that would actually like monitor these services itself. So if there's a failure in one, you could actually know about this failure. Monitoring effects in general, it's a bit more complex for you to have the services without having people that are there to monitor the services like on a go and understanding this development and deployment itself. So you need like an DevOps to actually do this aspect of the platform itself, because if you think about microservices, then you start thinking about having a continuous integration and development whereby you have different type of pipelines that are actually like promoting different stages of the rollout itself. So you can actually like roll out 100% in microservices if you want to be safe in general, because you would want to have a stages of rollout, and these are being managed by DevOps. So, and also monitoring and checking of error logs and understanding the service communication within each services to ensure that you can actually resolve this issue when they come in time. So it requires high DevOps, it requires high monitoring efforts, and also it increased the operational costs. So the increase in operational costs from different instances that you're actually different instance that you are spinning out and you're deploying, due to the fact that these are multiple services. So obviously you make availability of multiple servers to actually house these services you're doing, or multiple or storage unit, whatever you're doing would have to be like in multiples because you're having different services that are actually using these resources. So when you're thinking about microservices, then you start thinking about the cost implication, the knowledge in the team, knowledge in DevOps, knowledge in monitoring, knowledge in understanding data in general, how you can make your data more consistent in the distributed system, how you can solve complex infrastructure and toolings, and understanding various methods whereby you can use to mitigate and ensure your service is uptime. So it's important for you to arm yourself with this so that you can actually be able to effectively spin out microservices and services and microservices itself. So let's talk about when to choose modular monolithics. So when would you want to choose a modular monolithic architecture? So you would want to choose it when you're in a small to medium team size. Yeah, it's important to understand this because when you're thinking about microservice, then you start thinking about large scale. But with small to medium sized team, you can actually easily manage a monolithic application, and you can actually structure it very well for you to have separation of concern and be able to actually ship these services. So, and also you could think about choosing monolithic whenever you have a new rapidly changing product. And these, when you're starting out as a startup, it will be very, very important for you to think of ways to make your application more monolithic, because you can actually easily develop new feature, ship them out, get feedback from the customers, then reshape. So it's easier for you to like spin up features, to like add more features and actually get them tested and get feedback in a monolithic pattern, compared to when you're thinking about microservices whereby different services have to communicate to actually make a feature. So it's important to actually look inward into how the product itself, it's how well you know the product. Like on clear domain boundaries low. So like when you're going to a new domain, it's important for you to test it out with a monolithic application to actually understand what the domain is all about, and for you to be able to like iterate on your changes and to iterate on the new features you're actually going towards to the market. So it's important for you to have this understanding of actually making these making these features or whatever the architecture you're using to be able to be compatible with the product itself. So if you're sending a new feature, it's important for you to understand how quick you want your feedback and how well you understand the domain for you to pick up various architecture. And monolithic is very good for you to test these hypotheses that you might have. So if you need fast development and delivery, you would want to choose monolithic so you can easily like develop a feature. Since everything is housed in one, you have your services that you could actually like increase, and you have your repository, you have your controllers, you can actually easily like add new functions that would actually resolve whatever feature it is you're trying to go to the market with. So it's easier for you to like do a fast development and deliver to your customers. And it has a limited DevOps experience and budget. So if you have limited number of DevOps on your team or experience in your team, or you don't have the budget to actually like get these tooling that would actually do this, it's important to be at the safer side with monolithic at first. Then when you scale up your product and when you scale up the number of teams and the experience or the budget itself, then you can start thinking towards microservices whereby you can migrate bit by bit. But then I think it's very important to know that it's require a lot of DevOps experience and budget whenever you're going into microservices. But in a monolithic, you could actually have your application spinned out from an E2 instance, and you have your load balancer and everything on it, and you can actually like deploy without having much experience of DevOps. And your budget might not be as huge as that, but then you can still have an application that actually fits your customers. So it's important to think about this these listed out options on when to choose monolithic. Thank you. So when to choose a microservices? So like I said, in large distributed system, so it's important for you to think towards microservices so that you can have more fault tolerance, resilience, and a bit more availability. So when you're thinking about trade-off between both, you need to understand that when you're choosing a microservices, you would have this importance of availability as a case for you to actually think, especially in large organization. They require very very high uptime. So you're thinking about availability. You're thinking about the fact that the team is distributed too. So different team with different domain knowledge, and this would help you to have a very synced type of distributed organization with a very good product if it's well managed. And also you think about stable and well understood domain, which I mentioned earlier. You need to have the domain knowledge of that particular service to actually be able to have a distributed service. So having a domain understanding of the particular domain the service is at it's a key in this architectural pattern. So you choosing it, you need to have a domain knowledge of that particular. So it's not as if you're testing, or more of developing a feature that's well understood. So you're not using a microservice to actually test a new feature, or how the customers would actually give you feedback to iterate on a feature. So it's important for you to understand that you should well understood the domain for you to start thinking about microservices. So microservice is more like you applying a way to actually like reduce the workload, for you to like scale more horizontally than vertically. So it's important for you to understand the domain very well. And also different components can scale differently. So especially when you have like I mentioned, you have bills payment, you have transfer, you have accounts, you have dispute. So you want to scale them in different way based on the user needs or based on your customer needs. So it's important for you to think about how you can scale out this. Then you start thinking about microservices, because it's easier for you to like scale out the bill payment. But then if the transfer is not being well used that much, then you can actually reduce the resources that's on transfer. Or if the transfer is more used at a particular period of time, then you can actually scale out the transfer and reduce the resource. So you can easily distribute resources across your services when you're using more of a microservice compared to when you're using a monolithic application, whereby you have to scale out the entire application at once and you're having resources not being well utilized. So microservices help you to actually utilize those resources, yeah, very well. Then you think about need for independent release cycles. So you could actually release a version of bill payment while the version of transfer has been probably since last year. So it enables team to actually release more feature independently, since they are the domain expert of a particular service, compared to when the application is single as a whole. Then you have to like make a new release for the entire application. So you can see how this would actually really really help in understanding how large organizations could actually release various features of different products and services without affecting the general over scope of the actual product. So it gives you that edge of you having multiple release cycle of one single service, compared to when you have to release everything in a single go. So yeah, it's important to see this as a avenue or an advantage over monolithic. And also maturity of develop and automation in place. So when you have mature develop teams and also automation in place, like you have the code fresh, you have the Git pipeline, whatever pipeline it is that would automate this uh, integration of services or communication within these services, it's important to have them in place for you to choose a microservices. Because if that's not in place, then there will be a lot of issues. You have the DevOps, you have the users that could, you have the engineers that could actually understand the logs, monitoring, tracing of this in an event of failure, or event of incident in any of the services. So it's important for you to think about how this automation and DevOps ability of your team is actually well grounded for you to think into us microservices. So it's yeah. So let's go. So what are the key takeaways for this architecture? So architecture is a business decision. So first is whenever you're starting a business or whenever you're thinking about business itself, you need to think about the cost implication of it. So even when you're choosing an architecture, you think about the cost implication, you think about the knowledge, you think about how you understand well the architecture itself. So in often, like oftentimes, if you want to start a business, it's best for you to start in a monolithic architecture. So when you gain more domain knowledge and when you see the need for you to segregate these services or controllers or functions you've done in the past, then you can start scaling out bit by bit into different services. So an ideal situation, if you want to start up your business itself, you will be thinking about going inwardly into a monolithic pattern at first. Build up the business itself, like build up the understanding of the domain, get quick feedback from your users and clients to understand how the business actually works in general, understand the edge cases, understand the various domain that you could actually split this monolithic architecture into different services before keying into microservices. So microservices actually solve organization scale, not technical scale. So even you can use different languages or different understanding of different programs to actually write a service. But it's important for you to know that when you're scaling an organization, then it's actually being you're solving an issue of product whereby you have different services that would actually come together to create value for the organization itself. So you're not solving technical debt. No, you're more of solving an organization product point of view or creating values. So you choosing microservices as a startup that doesn't understand in domain knowledge, you might actually come into issues or whereby you're more like solving technical skill, which might not be we might not be like you having that concrete knowledge of the domain. Then you have a scenario whereby you're rewriting different services because they can't actually fulfill the aim of it. They can actually go for the aim of which they are actually being created for. So it's important for you to understand and differentiate the difference in you scaling an organization and you having a technical skill. So yeah. So evolve architecture as complexity grows. So when you start with a monolithic and you're seeing complexity over services and different services are interbound in the sense that you're having different concepts and you're understanding the domain and you're growing in complexity, then you can start spinning out the services into various nodes. This would help you to actually like be able to scale and grow these various services. Then you can do it more like chunk by chunk as the user needs keep increasing. Then you keep trying to create more features that are well grounded in various domains, so you can have more separated value chain instead of having a singular one, which you would actually have to start worrying about scalability. So evolving an architecture is actually better whenever you're thinking about, okay, moving from monolithic to microservices. So you trying to like evolve the product itself and create value, not technical scale. So, and also avoid premature optimization. So this is where you're trying to like optimize a solution that's still well in iteration. So you're still trying to discover the solution and you're trying to optimize it or trying to scale it into services that would actually cost more, create more cost towards the business itself compared to when you So when you being grounded on the domain and spilling out more new services after understanding of the technical domain of that product itself. So I think the key takeaway here is for you to start small as a monolithic application whenever you're designing your startup or whenever you're building your product. Start small as a monolithic application, understand the domain, get the feedback from client, get the feedback from users, understand the feedback, design a more structured domain. Then when the complexity grows, then you start fanning out into various services. So you would have more concrete structure then you can start having different squads of different teams handling various domain aspects. So you don't have a domain that you don't know and you're just building out various service. Then you have isolated services that are not in use or not needed for the value goals that you're trying to actually deliver. So in general, so if you're taking anything out from today's lecture, you should understand that when you're designing, when you're going to market, it's important for you to think about how your services would evolve. So you would think about, okay, getting the product out there, faster delivery. You want to iterate over your future, then go monolithic. You have the features already. You understand the domain. You want to scale out, then go into microservices. Yeah. So thank you very, very much. And you have a lovely day.